Okay, what we're going to do now is look at a couple of ways to apply the SUVAT equations, and just to remind you, okay, we're going to start with the two basic equations. V is equal to U plus AT, and S is equal to U plus V over 2 multiplied by T. So here's a question from one of the Edexcel textbooks. It's in exercise 2A, it's question 13. So the question you can read here. So I'm going to jump straight into how I do it. Firstly, I write out SUVAT. Okay, those are my 5 variables, and it helps me to ascertain which equation I'm going to use. So my initial speed is 2, my final speed is 7, my time is 20, and I want to know what the acceleration is. So this tells me that I need an equation with no s in it. So that equation is V is equal to U plus AT, and I simply substitute in my values, rearrange and cancel some stuff down. I get that A is 0.25 meters per second squared. Remember, if you find this is going too fast, just pause the video and read through what I'm doing. Then for part B, it asks about the time taken for the particle to move from B to C. So again, I repeat the process. I put my variables in. I decide which equation I want to use. So again, I want no s. So here we go. I've got V is equal to U plus AT. Now, my V is now 11, 7, and then everything that was here. And in this case, I actually used my A from the previous question. Okay, from the previous part. And obviously that's quite a common technique to carry a piece of information through and slowly build up through your video, through your question rather. So rearranging, I get that my time is 16 seconds. Not too hard. Okay, then part C, I'm asked to find the distance between A and C. Okay, so if A, it's doing 7 meters per second, and at C it's doing 11. It's got a constant acceleration for that entire time. I want to find the distance or the displacement. My time is irrelevant, so I pick V squared is equal to U squared plus 2AS. It's an equation with no T. And so I have all of the variables to put in, rearrange, rearrange, and that was my final answer. And remember to include the units. You always use SI units, so distance in meters, speed in meters per second, acceleration in meters per second squared, time in seconds. Okay, if anything's not in those units, you need to convert. Okay, in this next question, we're looking at something that's a little bit more difficult, but I've started off with the variables. I've got the variables written down, and so I've picked my equation. I need an equation with no s in it. So if you look at the question, it looks like you've only got 2 pieces of information. There's 12 meters per second and there's 0.8 meters per second. And obviously you need 3, but what you've got to take into account is that because the object comes to rest, its final speed is 0. And also, because it's slowing down, it's decelerating, we have this negative acceleration. So what I'll do now is I'll substitute the values in. So I have 0 squared is equal to 144 plus 2 times by minus 0.8, and obviously the s at the end. So rearranging that, I now get 1.6 is equal to 144. I forgot my s there. So s is just 144 divided by 1.6, and then when you work that out, it should be, let me just check, 144 divided by 1.690. Okay, a nice number. 90 meters, obviously keeping everything in SI units. So the next question asks us to look at the speed of the stone when it's travelled half of that distance. So we look half of the distance. Okay, now half of the distance. The distance is 90. Half of the distance is going to be 45. Okay. Let's just change that. I started this earlier and then realised I'd made a mistake. So we've got 45 meters. We've still got the same deceleration. 45. So we've got v squared is 144 plus 2 times 45 times by minus 0.8. Let's get this really tidy. Minus 0.8. So my 2 times by 0.8 is a minus 1.6 times by 45, and a 1.6 times by 45 is going to give me 72, so minus 72. So 144 minus 72 is 72. So I then look at square rooting the 72 and I get 8.49 meters per second. Okay, and that's it done. Okay, so a little bit harder than the last question we looked at. Same process though. SUVAT, variables, pick the equation, substitute, calculate, rearrange, answer. Not forgetting your units. Units are pretty important with mechanics. Because it's applied, my view on it is a number's just a number and it's the units that give it the meaning. Okay, so hopefully this has helped. If you need to watch it again, watch it again.